Lesson 23 is density, and we're going to look at two types of density. The first is going to be area density, and the second will be volume density. So density, when related to area, is the measure of an amount per unit of area. So a couple different examples of area density could be like how densely populated a city is, meaning like how many people live per square mile or per square unit of that city. Another example could be like how densely packed your garden is, like how many plants are in it, if the plants are kind of more packed in close together or more spread apart. Maybe how densely like forested an area is, so how many trees there are per square mile and so on. So density related to area is just really like how much stuff is packed into that area. So we'll use density of area equals the amount divided by the total area to find our densities. So example 1, about 1,400,000 people live in a city. The city has a land area of 320 square miles. What is the city's population density, which is people per square mile? So we have the formula, but I just kind of want to talk about how you could approach it in just like a more general sense, if you feel comfortable with it, and then kind of use the formula to fall back on. So in the problem itself, it says, what's the city's population density, which is people per square mile. So when you see the word per, that typically means like division or like kind of creating a fraction, think like miles per hour, and so on. So people per square mile, that's like the amount of people, like we have here, divided by the total area in this city. So we don't necessarily need the formula, we can just kind of use it to fall back on, but people per square mile is how many total people are there, divided by how many total square miles are there in the city, and that'll give us the density of that city. So reading back through the problem, it says that there are about 1,400,000 people in the city, so that'll be our amount. And then the city has 320 square miles. That'll be our area. And remember, anything that's like in terms of area always has squared units, so like squared miles, square feet, square centimeters, anything squared, it will be area. So for our amount, we'll put in 1,400,000 and then divided by 320. So 1,400,000 divided by 320 square miles is going to give us 4,375. And I think to even make a little bit more sense of this, you can add kind of like the units to the numerator and denominator. So this was 1,400,000 people, and then this was 320 square miles, and we ended up with 4,375. And then what that's giving us is people per square mile. So 1,400,000 divided by 320 gives us 4,375 people per square mile, and that's the density of the city. So to kind of compare it to maybe some other potential cities, if you had a city that had 6,000 people per square mile, we would say that city is more densely populated than our city in our example. If you had a city that was, say, maybe only 1,000 people per square mile, we'd say that city is less densely populated than the one in our example. Okay, moving down to 23.2, this is volume density. So density, when related to volume, it's also called mass density, and it's a measure of the mass of a substance per unit of volume. So one good example for like volume density is, you know, if you pack up like a bunch of boxes and you're moving, the boxes may all be the same size, but they may not be the same weight, and that like weight depends on how densely packed they are. So we can use the formula density of volume equals the mass divided by the total volume. So example 1, the moving box example, but a moving box has a volume of 1.5 cubic feet and a mass of 9 pounds. What is the density of the contents of the box? So we're trying to find D, density. And so to do that, we need to figure out, okay, what is the mass? It says that the moving box has a mass of 9 pounds, so we'll put that 9 in for the mass. And we need to know volume, and it says that the moving box has a volume of 1.5 cubic feet, so we'll put that in for volume down here. So the mass, that was 9 pounds. And then divided by the volume, that's 1.5 cubic feet. So we'll do 9 divided by 1.5, which ends up being 6. So this is like 6 pounds. And then per 1 cubic foot. So the density D is 6 pounds per 1 cubic foot of volume. Okay, moving on to example 2, it says a metal plate has a density of 9.2 grams per cubic centimeter. If its mass is 2.3 kilograms, what is the approximate volume of the metal plate in cubic centimeters? So in the first example from this section, it asks for what is the density. This example is asking for what is the approximate volume. So we're trying to find volume here, so we're like kind of missing something different. But because we're given the density, we're still able to use the density formula to find what we need. So we just need to figure out kind of what goes where, and then that'll allow us to solve for the volume. So this problem says that a metal plate has a density of 9.2. So we'll go ahead and put that 9.2 in for D. And that unit on that density is grams. So it's a density of 9.2 grams. And then the mass is 2.3 kilograms. So we'll end up putting that in for mass. But if the density is in terms of grams, then the mass should also be in terms of grams because we want them to be like the same units essentially. So if I need to convert 2.3 kilograms to grams, I have to multiply that 2.3 by 1,000. So if I want to change that 2.3, it'll be 2.3 kilograms, and then times, there's 1,000 grams per every 1 kilogram. So if I do it like this, the kilograms will cancel each other out, and then I'll multiply 2.3 times 1,000, which would be 2,300 grams. So instead of putting in 2.3 kilograms, because that would be the wrong units, and for mass, I'm going to put 2,300 grams. And then that leaves us with just volume, which is what we're trying to solve for. So we'll just leave it as like V, a variable that we need to find. So I'm actually going to move this over. Sorry if it's kind of in the way. Not that far. Okay, so we'll put 9.2 in for D. And then that equals 2,300 for our mass, and then over V, which is what we're trying to solve for. So if you want to solve for a variable that's in the denominator, you need to get it out of the denominator because it's kind of trapped in there. So to cancel out that V that's in the denominator, I'll multiply both sides by V. So V, the V in the denominator with the multiplying by V, those cancel each other out. And then I have to multiply it over here too, and because of that, the V doesn't just disappear, which would be bad. So this will be V times 9.2 equals 2,300. And then I'm trying to get V by itself, so now I have like a 9.2 that's being multiplied by V. So to cancel that out, I'll divide both sides by 9.2. So the 9.2 divided by 9.2 will cancel out, and then I'll be left with V equals 2,300 divided by 9.2, which ends up being 250. And this was in terms of cubic centimeters. So the volume is equal to 250 cubic centimeters.